To decode string at index, the daily problem of 27/9/23. It's been a bit late, but given a problem, you are given an encoded string S, and when I say encoded string, you should know like what kind of encoding strings are there in Leetcode questions. Generally, mixture of strings and integer, where integer represent the repetition. So, to decode a string at a tape, the encoded string is read one character at a time, where the following steps are taken. If the character is a letter, then letter is returned to the tape. If the character is a digit, you write entire tape repeatedly d minus one more times. More times. So in total, it would be written d times uh, the complete string that you have written on the tape. So read the digit d, entire tape is repeated. Now given integer k, return the kth letter in the decoded string. Okay. So in this case, lead to code 3. So your tape will look like you will first write lead to the tape LEET, then you see 2, then you repeat your lead again. So this is now the tape value lead. Then you see code, you will write code, then you see 3. So you will repeat whatever is present on your tape till now lead code is present on the tape. You repeat it 3 more times, you get like the same thing written 3 more times. Now you were asked about the index 10. You can see like in the complete string the index 10 would be something first lead then co. Okay, so that is the index 10. You can count it in this like 4 and then co. Yeah. Phew. How do you get this now? So to get this, there are a couple of ways. Like one is to get the complete string, but that is not feasible because the number again. So you can see the constraint for that. Like s can range to length 100, and when I say length 100, there is no repetition. How many times letter is there? How many times digit is there? If letter is there, we don't have any problem. But the thing is, when digit is there, you repeat the complete thing. So if a is written, then 2, 3, 4, 5, 9, 9, 9, 9, 9, 9. This is something. So a is 1, and then 2, repeat a, then 3, repeat these 3, 2 is 3 times, so 6, then into 4, into 5, into 9, into 9, into 9, and so on. So this becomes a really big string of containing only a. The example is this: if a comma this is written, this looks very small, would be let's say 10 or 20, 30 characters, but it's actually repeated more than billion times. So that is not what you can do to get the complete string, but what you can do is that k is limited to integer maximum. So you can somehow try to find k as soon as possible, and it will not be the case that the string you will be traversing more on a string. So you will be traversing only on the given string because there exists every word that every letter that you want. It's just that you have to find its actual position, and the position what you are looking for is mirror. It's not a mirror, but yeah, that how somehow repeats to get that on the position. So that logic you have to use, which is given in the problem, repeating the how the repetition is happening. But let's suppose you go for k now, keeping in mind that k is limited to integer maximum, and the main thing keeping in mind is that s is limited to 100 characters. So this is achievable. We go on s, and then we just enumerate the total number of characters written on the tape. So leet, currently the tape character is 4. Then you see 2. You don't make plus 1, because before that you was making plus 1 for l, for e and t. Now you make into 2. So whatever your n value is, the number of character written on tape is equal to n. This is the current, you can say, the size that multiplied by the integer written. So that is equal to now 8. Now you got that thing. So when you see that, okay, I got the current length equal to 8, I can only if k is equal to 6, I am able to handle k equal to 6 because I have seen 8 letters. Believe it or not, you have seen 8 letters. You have only seen 4 letters LEET, but um, the next 4 is just repetition of that. So you don't need to actually do anything. Just Now for the remaining part of the string, you just need to look out for this, how you can achieve k equal to 6 in that. So first thing which happens is that, okay, let's move one unit backwards, and now n was 4 and k is equal to 6 mod 4. Why 6 mod 4? Because we know that now it is going to be the repetition in the given string which is written on the tape. What is written on the tape? Lead is written on the tape. So this is just 4 letter, and I want looking for something like 6, but it is just repetition and coming up again and again. So if 6 mod 4 gives you 2, so that you know that it's the second character e. But how do you get the second character? You do not have that reference that it starts with l, right? Even if you had that reference, sometimes it could be possible that okay, that there are the given window which you got after the given window which you got is LWT, that does not contain an integer, but sometimes window can contain integer itself. Then there is an issue. So now what you do, so the logic goes like this. uh, First you find out that stopping point, where do you need to stop when n becomes greater than k, because 8 became greater than 6, so now it's time to stop. So LEET 2, this is what I have seen, and I know that k equal to 6, I will get into this. And I remove 2 because 2 is of no use. It's just to say that, okay, this is repeating 2 times, so that's how you got 8, but actually it is only 4 characters. So now you do you, you, your I, okay, I index is present on 2 initially, then you do minus minus because you say 2 is just for the sake of like the repetition. So I minus minus, now I is present on t, so I value is equal to, you can say 0 1 2 3, and s of I is equal to t. And what is n value? I said n is equal to 4. What is k value? I'm looking for something 6. But when I did this, that okay, that you are on LEET 2. When you move back from 2, you do n divided by 2, first thing. That's how n became from 8 to 4. And you do k equal to k mod n. K mod n. K mod n is now n is equal to 4. So k mod n is equal to k equal to 2. So now you are looking for something like the second character exactly. But you are moving backwards now. Now I is equal to 3, n is equal to 4, and k is equal to 2. So we move one unit more backward. I'm on e now. Now n is equal to 3, because every time when I move backward, I minus minus n. When I see a digit, I divide the n by that digit, so that okay, this is the repetition. The single character, like it's just, if it's just a English alphabet, it's just a one thing. But when it is something like integer, it means that okay, this is part which is getting repeated this number of times. So the overall, the remaining thing which we have is that divided by the number written. So for now everyone is just English character, so n minus minus n is equal to 3. Now you're on e, k is equal to 2, and I is equal to 2. Then you one unit more backward, n is equal to 2, k equal to 2. So when you see k mod n equal to 0, or even like in most of the cases it would be n is equal to k now. So then you got that the character which you wanted. But only in few cases it would not be in equal to k. Let's say if you in this complete string like lead to code 3, you try to find value of 12, so you get the value of 12 as like you complete the lead 2 times, so it is 8, then CODE gives you 12. So now n is exactly equal to k. But you do what's the way to check that? The way to check that is you see that okay, what is my last thing? My last thing is 3. So no, the last thing is not 3, last thing is e. N is equal to 12 and k is equal to 12, and the character is e. So when you see character is e, so now k is equal to n, so that's fine. But what if it was 24? If it was 24 character, so 12th of you will go like that, and then you do multiply by 3, which is 36. Now in this 36, you know that you are looking for 24. You first of all do uh, 36 divided by 3, which is 12, and k modulo n, which is 12. So it is k is equal to 0 now. Now k is equal to 0. So should you do anything other than that? If k is equal to 0, you know that E is your answer. So how do you return that? K is not equal to n. N is still 12. So then you return, if k is equal to k mod n is equal to 0, you return that character. So this is the logic. First you find out the stopping point. This is how, when n is less than equal to k, just increment your n, the current size. I think incrementing current size should be very clear, and the logic behind it should be very clear, because we are trying to reach the kth index. Okay, we are not somehow magically finding the kth index, not binary search on answer. Neither we are like making a complete string. We are trying to reach from 0 to k. So during our way, we see if it's a character, increment the one, increment by one your window or your current tape. If it is integer, you increment by multiplying that number. So this is your current tape length, and when you see it becomes greater than k. If it is equal to k, that's a separate thing. But yeah, if it is no longer lesser than k, then you come here, then you try to find out, okay, I know that, okay, I have already, either I am standing on that, or let's say if someone says 2, so you do L and then E. Now your window length is equal to 2, n is equal to 2, k equal to 2, and you do I minus minus. So you're standing on that, you just need to return that. But sometimes when I say lead and 2, you got, let's say, 8 as a current tape, and you're looking for something like 6, which is not directly present but indirectly you found it. So this is the way of finding it indirectly, and divide by equal to that number. And yeah, so whenever you make a stop page, yeah, the stop page is only in two cases: if you are currently standing on that index, or you are standing on a number, because number gives you that, okay, you just exceeded that limit by that thing. Okay, and yeah, otherwise you are standing on there. So when you're standing on number, first of all you do this, you divide that by number, and you k module equal to n. So this is your new k. So this is new k, and then you come back, keep on coming back till you find k modulo n equal to 0. So that is your stopping point. When k modulo n becomes equal to 0, that is the ith character is the answer. So then you break out or just return directly I. Or otherwise, if it is not integer, you are just reducing it by 1 unit. So keep on reducing by 1 unit till you find that thing. Okay, when k modulo n equal to 0, and then you return that. This is the way of returning it, because this is a character, and how I'm converting character to string is by adding it with the empty string. That's all. This was a today's daily and a good question, I would say. Okay guys, bye.